of intense heat still cooling as it continues to expand. Cosmologists are not only confident that they have unearthed the universe's past, but that they can also predict its future. Space, like the surface of hot-blown glass, cools as it expands. Just as flecks of color embedded in the glass move further apart the more it stretches, so do the galaxies. Space is expanding in all directions at once. Modern cosmologists are now trying to measure if this expansion will continue forever. How will the universe end? The key to the future of the universe was discovered long before modern astronomers built their giant telescopes. Back in the 1660s, when Sir Isaac Newton had an encounter with a falling apple and discovered gravity. Newton formulated laws of physics which formed the basis of modern science. Gravity may be the weakest force, but it's the force that holds the planets and the stars together. After Newton, perhaps the greatest scientist and mathematician of all time was Albert Einstein. Einstein had been an unremarkable student, and his first job was as a clerk in the local patent office. His general theory of relativity, announced in 1915, explained for the very first time how everything within the universe interacts: space, matter, even time. His calculations told him that the stars and galaxies should exert a gravitational pull on each other and should eventually collapse together in a catastrophic fireball. But they hadn't collapsed, so to make his equations work, he invented a special repulsive force. But it was a makeshift solution, and deep down, Einstein knew it. Then, a decade later, along came a man with the solution to Einstein's puzzle. Here, at the Mount Wilson Observatory in California, Edwin Hubble took the first steps towards forecasting the fate of our entire universe. Hubble was a World War I veteran and a brilliant lawyer. When he turned his renowned skills to astronomy, he came up with a remarkable discovery that would change the way we view the universe forever. He made the astronomical discovery of the century, that the universe was expanding. 75 years on, measuring the precise speed of that expansion is the job of astronomer Wendy Friedman.
What Hubble found was that almost all galaxies appear to be moving away from us. And this led to the idea that the universe is expanding. Here was evidence for the first time that the universe was actually in motion, that galaxies are moving apart. What that means is that you can essentially extrapolate backwards in time. It's like running a film in reverse. If galaxies are expanding now, then at some time in the past they must have been closer and closer together. And what that implies is that sometime early in the history of the universe, galaxies would have been much closer together. The matter in the universe would have been much denser and much hotter. And this gave rise to the idea of a Big Bang universe.
Hubble's revelation stood the astronomical community's understanding of the cosmos on its head. He'd used the same technique that police forces around the world use today to catch speeding motorists. Hubble used the astronomical equivalent of a police radar. Instead of using radar signals, Hubble measured the light that came from distant galaxies. He knew that their color would be slightly altered if they were traveling towards or away from us.
If an object is moving away from us, then the light from that object will be shifted toward the red part of the spectrum. If an object is coming towards us, the light will be shifted toward the blue part of the spectrum.
By determining just how much the color had been changed, Hubble could work out how fast a galaxy was traveling. It's an effect known as the Doppler shift, and it applies to both light and radar. Hubble found that all the light from all the galaxies was shifted towards the red part of the spectrum. They were traveling away from us at an incredible speed.
There have been dramatic improvements in the technology since Hubble's day, and we now have the advantage for the first time of being able to get outside of the Earth's atmosphere. That is, we can go to space, use the Hubble Space Telescope, named after Edwin Hubble, to measure distances to galaxies.
Modern astronomers have calculated that we, along with all the contents of our own galaxy, are traveling away from the nearest cluster of galaxies at 1,000,000 miles an hour. By the end of this program, the whole universe will have expanded 1 billion miles in all directions. Wondering if there is enough matter in the universe to stop it expanding is a prime concern of Professor Stephen Hawking. Born 300 years after Newton, Hawking now holds Newton's old job at Cambridge University. Hawking already knows that the visible galaxies do not produce enough gravity. He now suspects that the universe is full of invisible dark matter.
If the universe continues to expand forever, everything will burn out and decay. The amount of matter we observe in stars and gas clouds is only about 10% of what is required to stop the expansion of the universe and cause it to collapse again. However, there might be other dark matter that we can't see, but which can still affect the expansion of the universe.
Dark matter is everywhere. The reason we can't see it is because of its size. Particles of dark matter are so tiny they can pass through anything. Neil Spooner and a dedicated band of astrophysicists are attempting to trap dark matter particles called WIMPs, weakly interacting massive particles, a mile underground at Bulby Mine in England.
It just makes up so much matter, so much of the universe. It's at least 90%, and probably 99%. If it wasn't for this material, our galaxies would just fly apart. We believe that dark matter is composed of elementary particles that arose in the Big Bang, and they're around us all the time and they're passing through us all the time.
Neil Spooner and his team feel sure that any particles that could penetrate through 5,000 feet of solid rock would be dark matter. The team are attempting to record collisions between particles of dark matter and the atoms in a light-emitting crystal. But it's a long vigil that requires an unusual level of patience.
Occasionally, like about once a day, you might get one interaction, in other words. The particle comes in, strikes an atom, it recoils, and it produces a little burst of light, ordinary visible light, which we can detect with our instruments and then amplify and record into our computers.
It will take years, but if their equipment successfully detects dark matter, Spooner's team will have discovered the invisible 90% of our universe. But this may not be enough. There may still be too little gravity to stop the universe expanding for eternity.
It could be that the universe will basically expand forever and simply dissipate, and eventually will end up with a, if you like, a soup of rather boring atoms and dark matter diffused around, and it'll be a sort of slow death and on into infinity, and that'll be it.
For some, the challenge of predicting the fate of our universe is compulsive. Their passion for cosmology often turns into a lifelong obsession.
There are a lot of people engaged in trying to find out what the universe is, and I think it's mostly the same kind of